Hi.
Good, how are you?
Good. Okay. What do we got going tonight?
Alright, so, I had a practice quiz, or test, and there's a few I can, figure out early, so I just want to go over this.
Okay. Hold on a second.
Alright.
My knee against the brace in the desk. Okay, go ahead.
Alright, so, first question I can figure out is 2x cubed, plus 26x squared, plus 60x.
What was the coefficient?
Plus 60x equals 0.
60?
Yes, 60x.
What's the very first step when you have a problem like this? Always. 100% of the time.
Greatest common factor.
Okay. What is that? You're correct. That is the very first step. Greatest common factor. What is the greatest common factor? And consider both the number and the variable.
2x.
Good. What does that leave behind? By that I mean, what must be inside my parentheses such that when it's multiplied by 2x, it equals to what we started with?
It would be x squared.
That's right.
Plus 13x.
That's right.
Plus 30.
Yeah, and when I say that's right, I mean you should check it the moment you came up with that answer. Make sure that that multiplies to 2x cubed. Make sure that that multiplies to 26x squared. Make sure that that multiplies to 60x.
Mm-hmm.
Okay? And that's the way you should pretty much do all math. Is check at each step rather than waiting to the end. Because sometimes you have math problems that are like 11 steps long. And if you wait to the end and you make a mistake, you have no idea where you made it. So to avoid that, you want to check as you go. Now, that is a quadratic. I'm betting that can be factored. Otherwise, it probably wouldn't be on this a problem. And if we can factor it, we need to. Because they want a solution for x. The problem, I'm betting, says give the zeros of x or solve for x or whatever. And in order to do that, we have to factor this last quadratic. So tell me how to factor again. First step.
X on both sides.
Good. Second step.
Factors of 30 that had to be
Hold on.
13.
Second step is figure out both signs.
Oh,
For some
positive.
reason, everybody misses that. I mean, you tell me why that's the case. I don't get it. But 90% of my students, when I teach them how I factor, they want to leave out step 2. And step 2 is hugely important. What are both signs?
Positives.
And the third step?
It would be factors of 30, that had to be 13.
What are those?
10 and 3.
Okay. Now you have your answer. What are answers? And I'm going to tell you, because we had a cubic, we're expecting 3 answers.
Mm-hmm.
You get it? Quadratics give you 2 answers, cubics 3 answers, quartics give you 4 answers. So what are the 3 answers here?
It would be 3.
Nope.
And or -3, -10.
Okay. What's the
And
second
then
one?
-10.
What's the third one?
Uh, 0? I don't know.
Yes. In other words,
0?
the principle is that if you have a bunch of things multiplied together and they are equal to 0, then any one of the 3 could be equal to 0. So if we set that equal to 0, we get x equals 0. If we set this equal to 0, we get x equal -10. And if we set this equal to 0, we get x equal -3. All 3 of those are valid answers. And you need all 3 of them. You don't want to leave one of them out. And the one that most students leave out is this 0.
Mm-hmm.
Okay. What else you got?
Here, let me find it.
They have not taught you how to factor cubics, correct?
Correct.
So when you see a cubic, like the last problem, you know that there must be a greatest common factor that takes that x out. Because otherwise you wouldn't know how to do it. And trust me, cubics are hard. You have a quadratic formula that will solve any quadratic. You do not have such a thing with cubics. I can give you a cubic equation that would take a professional mathematician 45 minutes to solve. That's how hard cubics are. So if they give you a cubic at this level of math, it means you can always factor an x out and you're left with a quadratic, just like the last problem. And you know how to handle quadratics. You can either factor them or you can use the quadratic formula.
All right, so here's the next
What
one.
else you got?
All right, -7n, parentheses, 5n -2 equals 0.
Like that?
Yeah.
What should we do here as a first step?
Distribute?
Well, that would normally be a correct answer. But in this case, it's not. If we distribute, we turn this into a quadratic, correct? In other words, we get something like this. Well, that's not very easy to solve. And in fact, the way we would solve it would be to factor out a greatest common factor.
Right.
Well, that's the way they gave us the problem, was as it's already been factored. So we don't have to distribute it. We have 2 things multiplied together that are equal to 0. What does that mean? If I say AB equals 0, there's absolutely one thing you can say is true. What is it?
That AB has to be 0?
Okay. That means that A is equal to 0 or B is equal to 0. You cannot give me 2 numbers that multiply to 0, unless one of them is 0. I mean, think about it. 1/2 times 2, that's 1. 1/4 times 1/1000th, that's a number. The only thing that's equal to 0 is when one of the things equals 0. And it doesn't matter if you have 2 things multiplied together, or 3 things, or 4 things, or 5 things. You're going to run into an ACT or an SAT problem that says something like this. A, B, C, D, E equals 0. What must be true?
All of those
Not
equal
all of
0.
them. Not all of them. One of them.
One of them equals 0.
And it makes a difference. Because you're going to run into equations where you have 2 things multiplied together. They're equal to 0. And you're going to set each of them equal to 0. And one of them is actually not a correct solution. So what the first law of algebra says is that one of them has to be 0. But what we end up doing is solving for both of them. So what's the first thing I can write? In other words, what I'm telling you is that even though both of them don't have to be 0, that's the way you proceed to get a solution. And then you check and you find out whether both solutions work. So what's the first thing that has to be 0?
Yeah, negative.
What does n have to be?
0.
What's the second thing that has to be or can be 0?
5n.
Not 5n. That whole thing. That whole thing is what's multiplying this minus 7n. So 5n minus 2 equals 0. In other words, you have 2 things being multiplied together. You have minus 7n multiplying 5n minus 2. So you set each of them equal to 0 and solve. Well, what solution does this one give you?
Zero.
Solve this equation. Algebra is always about solving an equation. That's what algebra is.
So, that would be...
You can do
2,
it. Okay, go
that'd
ahead.
be 2 over 5.
Yeah, I'd actually rather you solve that in one step because it's very easy. Sometimes I'd rather you solve stuff one step at a time. But when you get problems like this, go ahead and get in the habit of solving it in one step. Now, what are our 2 solutions? There's one of them.
0.
What's the second one?
2/5.
Now, what you have to do is to plug in each solution and make sure that each solution produces an equation that's still an equation. Okay? So, let's start with 0. Minus 7 times 0 times 5 times 0 minus 2. What's that equal to?
That's negative, or that's 0. So
That's all
negative
you
2.
need to know. Do not even look at the second part. Once you decide that that is 0, you have 0 multiplying some number. That's always equal to 0. So, that's a valid solution. Now let's try 2/5. the other solution we came up with. So I'm going to plug in 2/5 for n. Now, are we still dealing with an equation? If we're still dealing with an equation, then 2/5 is valid. What's this part over here equal to? Minus 7 times 2/5.
I know.
Multiply that. Not using your calculator. Multiply minus 7 times 2.
Negative 14.
And the 5 is the bottom. In other words, the way you want to think of this is you got minus 7 over 1 times 2/5. Multiply numerators, multiply denominators. Okay, now I have to multiply that by 5 times 2/5 minus 2. Well, start from the inside out. What's that equal to? 5 times 2/5.
5 times 2/5 is like 2.
Good. What's 2 minus 2?
0.
What's minus 14/5 times 0?
Minus 14/5. That's 0.
Okay. Indeed, that is an equation. So both of those solutions are correct. Now, let me give you just a word of advice. Most equations are going to give you two solutions that are both correct. The ones that do not are the ones that have a radical sign in them, or an absolute value sign, or a log sign. So these are the ones to keep your eye out for. When you have an equation like this, say this, when there is a radical sign in the equation, be careful. You may end up with two solutions, but one of them doesn't work, and you have to throw that out. It's called an extraneous solution. Remember, if I'm multiplying two numbers together and getting 0, first rule of algebra does not say both of them have to be 0. It only says one of them has to be 0. So sometimes you get problems where only one of your zeros is correct. And the things to look for are radical signs, absolute value signs, and logs. Whenever you see an equation that's got one of those three, make sure you check for extraneous solutions. What else do you got, Blake?
Alright, let me find it.
Probably haven't had much of radicals, absolute values, or logs. But you will. In other words, there's not too many polynomials where it's just x or x squared that give you an extraneous solution. So keep your eye out for those three things. That's what's going to give you your extraneous solutions. But it doesn't sound like you're quite there yet in math. But you will be getting there soon. Solve that.
It's like
It's the first step. Get rid of the radical sign. Radical signs are ugly. They do nothing but make problems for solving equations. So the very first thing you want to do is get rid of it. How do I get rid of it?
you do it on both sides, or
You square both sides.
square both sides.
In other words, this is the square root of x plus 5. So if I square something that's the square root, got to do it to both sides. Well, the left side turns into x plus 5, always. In other words, the square root of b squared is always equal to b. Okay? Okay. So, what's the next line? If I got x plus 5 equals 100.
You would do minus, so x equals 95.
Yeah. And now we check it. And we get the square root of 95 plus 5 is indeed 10. So yeah, everything works out. That's a good solution. Now, when you only get one solution, it's almost always correct. It's only when you get two solutions that you have to be a little careful and make sure that one of them is not extraneous. And the way you do that is just by plugging it in, both solutions, into the original equation.
Mm-hmm.
We've got 5 minutes. One more problem.
I don't really have any others.
Well, let me give you one. I don't like that one. Solve that.
So I would do plus 25.
So just give me the next line. I know at this point you know how to do algebra enough that I know you don't have to describe to me what you're going to do. Just tell me the next line you're going to write.
Alright, so x squared equals 36.
And again, the next line?
You would square root both of them, which is x equals 6.
All right. This is the hardest thing for students to learn. That's not the correct answer.
Oh, minus plus.
There you go. Plus minus. Because minus 6 times minus 6 is 36. And plus 6 times plus 6 is 36. So both of those solutions are equally valid. Now, notice the only time we have to do the plus minus is when we're taking the square root of both sides of an equation. If I tell you what's the answer to that, what's the answer?
So, wait.
Yeah, this over here.
That's minus plus 6, right?
Oh, it's just 6. In other words, when I put the radical, this is very confusing, I understand. But when I use the radical sign, I'm assuming there's a plus sign in front of that. So it's plus 6. If I wanted minus 6 to be an answer, then I would have done this. That's minus 6.
Mm-hmm.
But when you are solving an equation by taking the square root of both sides, it's a whole different story. When I take the square root of x squared, I get x. But when I take the square root of 36, I get two answers. I get plus 6 and minus 6, which is a different problem than that over there. Math has dictated that when I say radical x, that means positive square root of x. If I want the negative square root of x, I'll say that. But if I say x squared equals 1, then x equals plus or minus 1. So it matters whether you're using a radical sign or whether you're solving an equation by taking the square root of both sides. If you're taking the square root of both sides, always begin your answer with the words plus or minus, not minus or plus. In math, they call it plus or minus. Okay?
Yep.
And that's the only real distinction, is the radical sign implies plus, and when you're solving an equation, you have to consider both the plus and the minus. And that's very important in algebra. All right. Blake, we'll let you go.
All right. Thank you very much.
Good evening. You're welcome. Talk to you later.
Yep, you too.